prove that cosine of x equals x cubed has at least one real root. All right. If we subtract x cubed from both sides, this equation becomes cosine of x minus x cubed equals 0. And we can call this our function f of x. So we're looking to see where this function has roots. And we know that this function is continuous because cosine and x cubed are both continuous. And the difference of continuous functions give us a continuous function. So we can use the intermediate value theorem. And so we want to find some values where we've got a positive function value and a negative function value, because then that will tell us that in between those two, we have a root. So let's start with 0. 0 is always the nicest. That's going to be cosine of 0 minus 0 cubed. Cosine of 0 equals 1, and 0 cubed is 0. So we've got 1 minus 0, which is 1. So we have a positive value for f of x. We also want a negative value for f of x. And I can see here, we've got this minus x cubed here. And so the larger x gets, the larger in the negative direction this is going to get. So we might want to pick a larger value for x. Here's the thing. If we pick a value like x equals 2, we're going to have to take cosine of 2, which will require a decimal approximation. But if we pick a multiple of pi to make the cosine turn out nicer, we're going to have a pi cubed here, which also is going to require a calculator for a decimal approximation. So really anything we do here, we're going to need a calculator. So I'm going to pick 2 because I know that 2 cubed is 8, so that's going to be subtracting something pretty big. So we've got cosine of 2 minus 2 cubed, which of course is going to be cosine of 2 minus 8. And we can use a calculator to get an approximation. And of course you want to make sure that you're using your calculator in radians mode, not degrees, because whenever we're looking at trigonometric functions, those are in radians. And here my calculator gives me approximately negative 8.416, etc. We don't need to be more specific than that. All we need to know is that this was negative, which it is. So the intermediate value theorem, the IVT, tells us that we have a root between 0 and 2. And so we're good to go. One quick note here, that is not necessarily the only root. There may be other roots, there may be other solutions to this equation, but we weren't asked to find all of them. We were asked to just prove that there's at least one. So once we've found an interval where we know there's going to be at least one, our job is done and we're good to go.